Hi everyone, my name is Makumba Gerard of EduMath. In this video, we are going to look at the error propagation in subtraction. But hey, before we continue, if you are new here at EduMath, consider subscribing and hitting the notification bell such that you can be notified of the new videos that we make every day. So let us get straight into it and see you there. Error propagation in subtraction. We are going to have a guiding question. So our guiding question is right there. Show that the maximum error in A minus B is magnitude error A plus magnitude error B. We have seen that EA, that is standing in for error in A, EB standing in for error in B, right? Let us get straight into it. Solution. Let us say let Z be equal to A minus B and EZ to be the error in Z. Yes, so if A and B have errors, then Z will have an error when you subtract. So let us get started by adding both sides the errors. So you have Z plus its error is equal to capital A plus its error minus, here I open brackets, B plus its error. I can open the brackets there. This is the same as Z plus its error equal to capital A plus error in A minus B minus the error in B. Now we are going to collect like terms, errors together, and then the real values also together. So we're gonna have Z plus error in Z giving us A minus B plus error in A minus error in B. Now because we are interested in errors, we have to make Z the subject because we are interested in errors. So Z is equal to A minus B plus error A minus error B. Then you have brought Z from this side to this side, so it will become minus Z. But remember, we said that let Z to be equal to A minus B, and yet A minus B is here, so that means this is actually Z. So we have Z being equal to Z plus error in A minus error in B minus Z. So this Z and that Z will vanish and we shall remain with error in Z being equal to error in A minus error in B. Now, absolute error on both sides will now be error Z is equal to the magnitude of error A minus error B. Okay. Next, from the triangular law of inequalities, we can further simplify this. We shall have error in Z is less or equal to, we simplify this by redistributing the magnitude throughout. So we have error A plus negative error B, right? This is what the triangular law of inequalities says, and this here, error Z less or equal to the error A plus, now because of magnitude, the negative is going to be absorbed. So the purpose of magnitude signs are to absorb negative and make the value a positive. So error. Then since error of Z is less or equal to this, alright, that means the error in Z is maximum when it is equal to this, because here we have two options. Z, error in Z is either equal to this or Z is less than, strictly, if we are to interpret this. So the maximum is what we are interested in, and it is the one which is equal to the error in A plus the error in B. This is as required. Now we can base on this to compute other things like the relative error. So relative error, this here is equal to the absolute error divided by the exact value. But what is the absolute error? It is right here, error in A plus the error in B divided by the exact value, which is A minus B. This here is the relative error. We can go ahead and get the percentage relative error. Percentage relative error is equal to relative error expressed as a percentage. So we're gonna have relative error times 100. So this is gonna be the error in A plus error in B divided by the exact, which is A minus B, times 100. So this here is the percentage error. Having derived that, we are now going to use it in an example. So our question is right there. Given numbers x is equal to 2.6754, y is equal to 4.006, they need us to state the possible errors in x and y. So in other words, they need us to find the tolerance error in x and y. We shall do that. Find the absolute error in x minus y. Find the percentage error in x minus y. Let's get started. Part A, they need us to find the error in x, the maximum possible. The error in x there is equal to a half times 10 power negative the number of decimal places. So we have here, these are 4 decimal places, so this is negative 4. And this here is 0.00005. Then the error in y, the value y, this here is a half times 10 power and negative number of decimal places. So this here is power negative 3. So when you compute there, the error here in y is 0.0005. So part A is done. Okay. Next, we are going to look at the maximum absolute error in x minus y. So from up here, we have that the maximum absolute error in z, which z was equal to a minus b. This is equal to error in a absolute plus absolute error in b. So we are going to extract that formula and use it as a fact. So now we have that error in x minus y, absolute is equal to the absolute error in x plus the absolute error in y. So this here, when bring this, so absolute error in x is 0.00005 plus absolute error in y, which is 0.0005. So this here gives us 0.00055, and this here is the maximum absolute error in x minus z minus y. Now someone can do this. Actually, if you watch the previous video about error propagation in addition, you're going to use this alternative, that the maximum absolute error is equal to maximum value minus the minimum value divided by 2. Please give it a trial and see if we get the same answer, right? So we are going to part C, where we find the percentage error in x minus y. Percentage error is equal to the absolute error divided by the exact value times 100. But what is the absolute error? The absolute error is right here. Now what's the exact value? Exact value is x minus y. So we have here 0.0005 divided by the exact value, which is x minus y. Our x is 2.6754 minus 4.006. This time was 100. Put this in absolute signs. So this here gives us, so when you subtract the denominator here, 2.6754 minus 4.006, you're going to get a negative value. But because of the magnitude signs, the negative is going to be absorbed such that we have a positive value here. The absolute error is, so this is giving us 0.0413324 significant figures, cost percent. So I have reached the end of the solution to our question here. Now we need to have one number, practice this knowledge. So given the values of A, which are this, B, that, find the absolute error in A minus B. Find the percentage error in A minus B. So this is what we have to go and try out. Alright, thank you very much for being part of my good audience up to this point. I want to say that if you are new here at EduMath, consider subscribing such that you can be notified of the new videos that we make every day. Also consider recommending your friend who is a fellow mathematician just like you, who is looking for an A. Refer them to EduMath. And I want to thank you very much and have a good time. God bless you.